Okay, section 2, chapter 5, section 2, some notes, and this is going to be dealing with polynomial functions, evaluating them, graphing them, and the easiest way to graph them is with your calculator. So have your graphing calculator handy, but first we need to recognize what a polynomial function is. And a polynomial function is a function that has the form of one of these guys that you see on the screen right now. And notice that one of the ways that we can tell it's a polynomial is that each of these different types of polynomial that you see, they all have integers for exponents. Okay, and so for example, a degree of 0 is called a constant. That's a type of polynomial. Well, that would be like something like f of x equals negative 14. Okay, it's a constant. The x is being raised to the 0 power, x to the 0 power, and anything to the 0 power is 1. Okay, so this guy right here, f of x equals negative 14, that's a constant. A linear equation, those are the ones that you talked about a lot in Algebra 1, and those are problems that look like this. Say 5x minus 7. And the reason it's linear is the largest degree, the largest power on the x's, on the x in this case, the largest power is a 1 right there. We just don't ever write that down. So anytime you see something to the, just a variable, then that's to the first power, and that's all you got. A quadratic would be something like f of x equals 2x squared plus x minus 9. Okay? And again, when you look, the largest number in the exponent is a 2. And that gives us our quadratic. That gives us our degree of 2. What about a cubic? That's going to have the largest exponent will be a 3. So it would be something like this. X cubed minus x squared plus 3x. 3x minus 4. This would be a cubic. And again, the degree is determined by the largest exponent in the function, as long as that exponent is an integer. Okay, so this is the largest exponent is 3, so it's a third degree. A quartic is a fourth degree equation. A fourth degree equation means the largest exponent is going to be 4. And this would be an example of a quartic equation. And again, we know it's quartic because the largest degree, the largest exponent in integer form is a 4. So in this example, what we want to do then is we want to check out these different functions that have been given to us and determine if they're polynomials. And if they are polynomials, write them in standard form, give the degree, give the type of polynomial, and what the leading coefficient is. So the thing that's really important on this is the powers on the variables. And so I'm just going to go through and tap these powers so we can have a look. Alright, so these are the things that we are really interested in. And in order for us to determine if they're polynomials or not, we have to look and see what these exponents are doing. So let's just look at h of x. Now h of x, this is a function of x that's just like saying y equals. Okay? And when I'm looking in here, I'm looking for exponents that are not integers and are not positive. And I'm looking, and I've got x to the fourth, and I've got x squared, and I've got a 3. Well, this is a polynomial. This guy is a polynomial. He satisfies all the requirements we need to have a polynomial. So that's all good. And what we're going to do then is write him in standard form. Well, he's ready to go. Largest degree to the left, largest exponent to the left, smaller exponents to the right. There's my standard form. It's a fourth degree because the largest exponent is a 4. And the leading coefficient is a 1. Okay, the leading coefficient is that number right in the very front. In this case, it's a 1. Let's go over here and look at g. So on G, we're looking at all the exponents, and the exponent in this case is a 2 and a 1. I forgot to mark him. There he is. He's a 1, even though we don't. And there's a 1 there, and there's a 1 there. Even though we don't write it, it is a 1. And so let's rewrite this guy in standard form. He also is a polynomial. And the reason he's a polynomial is that all of our exponents are positive integers, or 0 integers, or 0 for an integer. So in standard form, this would be the largest degree on the left. So pi times x squared plus 7x minus the square root of 3. This is how that polynomial would look in standard form. And this is a second degree. And again, we know it's a second degree because the number, the largest exponent is a 2. And then we would say that our leading coefficient in this case is the number in front of that x squared. So our leading coefficient is pi. And pi is okay. That's a coefficient. It's a number that doesn't change. Look down here at the f of x guy. And when we look at him, we're looking at the exponents. And right here, I've got a problem right off the bat. I got a problem right here. This exponent is a negative 1. And because that exponent is negative 1, this guy cannot be a polynomial. It's not going to happen. All the polynomials have to have positive integers or 0 for their exponents. So this guy is not a polynomial. He's still a function. We can still graph him. He just doesn't satisfy the definition of a polynomial. Let's look at the last guy here, k of x. Again, this is the same thing as just saying y equals, and everything's okay except right there. And again, that's not a positive integer or a 0. And so because of that, we would say also that this guy is not a polynomial. And if he's not a polynomial, then he doesn't have a degree. And it would be difficult for us to figure out which number is supposed to be the leading coefficient. So we're done with these two guys on the bottom. So the two top functions are polynomials, the two bottom functions are not. Okay, for this example, what we want to do is we want to evaluate this problem using direct substitution. In other words, if we look at the graph of f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8, we're saying, look, if I graph the line y equals all of that, 2x to the fourth minus 5x cubed minus 4x plus 8, if I were to graph that, I'm really interested in what goes on when x is 3. So we just substitute 3 in for all the places that we have x. 2 times 3 to the fourth minus 5 times 3 cubed minus 4 times 3 plus 8. And we just work out all this math one piece at a time. Well, this is going to be 2 times 81 minus 5 times 27 minus 12 plus 8. 2 times 81 is 162 minus 5 times 27 is 135, and then minus 12 plus 8. So now just start combining these guys down. 162 minus 135, you can punch that into your calculator if you want, or do it in your head, or whatever, but that should be, let's see, 162, I'll just work it out over here, minus 135. So the old-fashioned way, it's going to be a 727. So 27 minus 12 plus 8. 27 minus 12, that's 15. Plus 8 is 23. And that's how you would use direct substitution. Like, they tell you a value for x, you solve it. Another way that you can solve that same exact problem is using what's called synthetic substitution, which is very similar to synthetic division. And these are very handy things to have. And so what we want to do is we want to list off all of the coefficients for our problem. The thing that we have to really pay attention for, and this could be something that'll trip you up, is we need to list every single power of x. So I've got 2x to the fourth minus 5x cubed minus or plus 0x squared minus 4x plus 8. You have to list every single power of x all the way down. And then we're going to take those coefficients and we're just going to write them down in a row, just the coefficients only. And we're going to put them right here, and we're going to take the number that we're interested in, which in this case is the 3, and we're going to put it over here in its own little cage. And then when you do synthetic division or synthetic substitution, it's really easy. It's basically a two-step process. You want to multiply, and then you want to add. That's all you need to do, multiply and add. And so what we're going to do here then is we're just going to bring down that very first coefficient, 2. Bring him down. And then now, once you bring down that first coefficient, that's the only thing that's different. So now we're just going to multiply and add. Well, what do I multiply? 3 and 2. That's 6. And add, that's going to be 1. And then 3 times 1, that's 3. And then add, that's 3. And then 3 times 3, that's 9. And then add, that is 5. And then 3 times 5, that's 15. And then add, and that's 23. And what we're going to discover is this guy right here is the exact same value that we got on the previous question. Take a peek. Here's the previous question. We did it a completely different way. Alright, we substituted that 3 in for the x, we got 23. Taking a fewer steps, we got the same exact answer. And this is called synthetic substitution, and it's a really nice little trick to have up your sleeve. Okay, the last thing that we're going to do in this section is graph some of these polynomials, and it's a lot easier to graph these on your calculator. You can get a really exact view, and then you can copy them by hand into your homework or whatever. But I'll graph each question, one on an Inspire and one on the 84, so that we can see how both of these would work, so that if you're at home and you're doing it. But basically, we're just going to put this into the grapher part of our calculator. So let's go ahead and look at the 84 first. Here's your 84, and we're going to graph this first function of x, the cubic, and hit the y equals part, and then just type in negative x cubed. Whoa, I need an x there. Negative x cubed plus x squared plus 3x minus 3. And hit the graph button. And you should have a fairly good graphing window on your calculator right off the bat. And if you don't, that's okay. You can manipulate the window a couple ways. One, you can zoom. And zoom standard is usually one, it gives you a 10 by 10 window going in the x and y direction in both positive and negative. You could go square, which makes all the pixels the same distance apart, so a square window would look like this. And this is actually the best shot, the most honest representation of this graph. And so there's our first graph right there. And a third degree, so it's got one side up, one side down. It's got a couple of bumps in it, some maximum and minimum values here. And this is all you do. If I'm going to graph an equation on the Inspire, then what I'm going to do is I'm going to open up a new document and choose a graph. And it automatically prompts me to put in an equation. So I'm just going to type in x to the 4th. So x to the 4th minus x cubed minus 4x squared. Oh goodness, all that stuff's still up there. X cubed, and then get out of the minus 4x squared plus 4. Alright, and then here's this guy's graph, and of course he's gives us a label for it. And there's the graph, and it's a pretty picture. It looks nice, And with the Inspire, you can graph several things at once, and you can see different graphs because they'll all be graphed in different colors. So there's your graph for that guy. And again, it's a fourth degree. Both of the sides point up. So in even degrees, if you've got an even degree polynomial, so if your polynomial is even, then you're going to have a graph that'll either be up on the edges like this, with who knows what's going on in the middle. And if you're an odd degree, you're going to have a graph that looks something like this, and on the edges, with who knows what's going on in the middle. So this guy is definitely even because both arms are up. This guy is definitely odd because one is up and one is down. And you can look, you know, at different functions. You can type them in and just play around a little bit and see what happens. But if I've got an odd function, and the leading coefficient is positive, then I'm going to have a graph that's going to look something like this. Okay. If the leading coefficient is negative, then I'm going to have something that looks like this. And if it's an even function, and the leading coefficient is positive, I'm going to have a graph that in general looks like this. And if that leading coefficient is negative, I'm going to have a graph that looks like this. And those are just kind of the basic shapes that you get when you graph these guys. And again, use your calculator to help you out. Your calculator is a great tool to use to give you an idea of what a graph looks like.